Dear students, good morning, good afternoon, and good evening. Based on the time zone at presently you are staying. First of all, I welcome all of you for our YouTube channel. You know very well, I am Selvamani Krishnamurthy, who is sitting in front of you. This is Data Science video lesson number 8. In this lesson, let us study how to perform statistical operations on array. That is what we are going to study. As usual, let us share my screen so that you can easily understand. I hope my screen is visible to all. Good. Lesson number 9. Topic is statistics on array. See, some statistical operation performed on arrays are mean, max, sum, and min. There are so many statistical operations are there, you know very well, standard deviation, variance, median, more like this, but we are going to study about only how to perform min, max, sum, and mean on array. For one dimension array, no need to worry about rows and columns. All are element, that's all. Min and max, you know very well, from the name itself, we can easily understand. Min and max returns minimum and maximum of all elements available in one dimension array. In same way, sum and mean returns total, mean or average of all elements available in the array. For two-dimensional array, we can perform both row-wise as well as column-wise. That means both row-wise and column-wise possible. If x is equal to 0, that means, for example, sum of x is equal to 0. It returns individual sum of every column. Two-dimensional array is made up of rows and columns. If you want to find out individual sum of each and every column, sum of x is equal to 0. Whereas if x is equal to 1, that means sum of x is equal to 1. It returns individual sum of every column. So individual sum of every column will be returned if you are using sum of x is equal to 1. What will happen if x is not specified? If axis is not specified, two-array arrays will be considered as 1-dimensional array. That means sum will produce sum of all elements. Min will produce minimum of all elements. That you must understand. Let us proceed to a small program. See, statistics on one-dimensional array. As usual, import numpy as np. Array1 equal to np.array. In this case, I am creating a new array with 4 elements. 3, 6, 4, 2. That's fine. So array1 contains 3, 6, 4, 2. Array1 dot min. Out of these 4 elements, which is the minimum element? 2. Number 2 will be displayed. Max min, number 6 will come. Mean means all 4 elements will be added, divide by 4. That means 3 plus 6, 9. 9 plus 4, 13. 13 plus 2, 15. 15 divided by 4. You will get 3.75. Array1 dot sum. All elements will be added. 6 plus 3, 9, as well as 13, then 15 will be displayed. Okay. So let us demonstrate the same thing in front of you. That means performing statistical operations on one-dimensional array. As well as I put import numpy as np. First, I need to create one-dimensional array. Array1 equal to np dot array. Within square bracket, some values. Randomly, I'm giving values. 3, 6, 4, 2. Then I need to find out minimum of all 4 elements available in array 1. Okay. In same way, we can proceed with max, then mean, then sum. This is for max. We can go for mean. This is for sum. I hope this is clear. Let us see the output. So I created one array called array1 with 4 elements. I want to find out minimum of 4 elements, maximum of 4 elements, mean of 4 elements, as well as sum of all elements. This is what my game. So expected out should be correct. Let us see. See 2, 6, 3.75, 15. I hope is it clear. So now let us see how to perform statistical operation on 2D array. So we need one 2D array. Same array 1 is reshaped by 2 rows and 2 columns. Okay, this reshape function makes or returns one array called array2 with 2 rows and 3 columns. See, array2 contains 2 rows and 3 columns. 3, 6, 4, 2. Fine. Now, I'm not mentioning any access. Okay, that means access not mentioned means 2D array will be considered as 1D array. Okay, so out of these 4 elements, all rows and columns, which is minimum 2. Similarly, which is maximum 6. Mean 3.75, sum is 15. Everything will be considered. No need to worry about rows and columns, even though if it is 2-dimensional. Let us demonstrate the same thing in front of you. I can insert one more row down here. Okay, so now I need one 2-dimensional array, np dot, sorry, array 1 dot reshape. I have 1-dimensional array that I want to make it as 2-dimensional array. Now array 2 is there. Let us check what contents available here is fine. So we are having 2-dimensional array, 2 rows, 2 columns. I can add one more cell here. So print array 2 dot mean. Same way I can proceed. Since we didn't mention axis, this 2D array will be considered as 1D array. No rows, no columns. Mean, and then let us check. I got the same result here. 2, 6, 3.75 as well as 15. Everything is it clear? So how to perform minimum in 2-dimensional array in row wise as well as column wise? See here, I have one array. I want to see maximum element available in each and every column. So I am giving axis equal to 0. So array 2 dot max of axis equal to 0. This is the first column 3, 4. Second column 6, 2. Out of these 2 elements available in first column, which one is maximum? 4. Number 4 will come. Out of these 2 elements available in second column, which one is maximum? Number 6. 6 will come. That means what? If axis equal to 0 means it returns maximum of every column. Same logic applied to max of axis equal to 1. If axis equal to 1 means it returns max of every row. Am I right? See the second one, 6, 4, I got it. This is the first row, this is second row. Out of these 2 elements, 3 and 6, 6 is maximum. Out of these 2 elements, 4 and 2, 4 is maximum. I hope this is clear. In same way, sum. In this case, we are seeing sum axis equal to 0. That means what? Returns the sum of every column. 3, 4 need to be added, 7. 6 plus 2, 8. Axis equal to 0 means returns sum of every row. First row, 3, 6, that is 9. Second row, 4 plus 2, that is 6. I hope this is clear. Let us demonstrate the same thing in front of you. I like to add one more cell here. Here. Okay. So already I have one array called array2. Let us print array2 first. Let us check. Now we are having one two-dimensional array 3642. Now I want to find out maximum of every column. That is max of axis should be equal to 0. In same way, see it here. Here, first column 3, 4. 4 is maximum. Second column 6, 2. 6 is maximum. In same way, maximum of every row. See it here. In first row, 3, 6. Maximum is 6. In second row, 4, 2. Maximum is 4. I hope this is clear. I can insert one more cell below. Same thing I can copy. Instead of max, I can go for sum. Sum. Individual sum of every column. Individual sum of every row. Let us check. So first 3, 4 is the first column. 3 plus 4, 7. 6 plus 2, 8. Fine. Second one, I want to find out individual sum of each row or every row. 3 plus 6, 9. 4 plus 2, 6. I hope this is clear. So let us proceed with the recap. So mean, max, sum, mean are some statistical operation performed on array. For one-dimensional array, no need to worry about rows and columns. All will be considered as all element. For one-dimensional array, min and max returns minimum and maximum of all elements. For one-dimensional array, sum and mean returns total and mean or average of all elements. For two-dimensional array, both row-wise and column-wise possible. For two-dimensional array, if axis equal to 0, that is, for example, sum of axis equal to 0, it returns individual sum of every column. Same way, if axis equal to 1, for example, sum of axis equal to 1, it returns individual sum of every column, every row. For two-dimensional array, if axis not specified, 2D array will be considered as 1D array. I hope is it clear. So today I stopped here itself. I hope all of you enjoyed this lesson. Very simple. In next lesson, let us study something extra. Until then, thank you, student. Have a nice good day. Bye-bye. See you.